sorry, I already had all this done and realized my phone wasn't in airplane mode, got a notification, it stopped my video. So, what I have going here, 8.1, we are talking about similar polygons. Okay, remember similar means they are not necessarily the same size, but they are the same shape. Okay, so here we just have a triangle drawn out. This is saying that triangle ABC is similar to triangle DEF. Okay, so what we're talking about mostly is our reductions, enlargements, things like that, scale factors, things that we've already talked about for the most part. Okay, so I have my small triangle, my larger triangle. Keep in mind that the order of these letters in our similarity statement matters, because I know A corresponds to D, B corresponds to E, C corresponds to F, AB to DE, BC to EF, AC to DF. Okay? If you need to stop this video as you're going through, if I'm going too fast, just go ahead and pause it and get things written down, however you need to handle that. Okay? Listing out our corresponding parts. So A corresponds with D. In similar shapes, your corresponding angles have to be congruent. Okay? So A is congruent to D, B would be congruent to E, and C would be congruent to F. Okay? Where this changes from similar to similar from what we used to do with congruent is that our corresponding sides now are not congruent anymore. Okay? Our corresponding sides have to have the same ratios. So, what that means is if I write a ratio of AB to DE, AB over DE, that ratio has to be equal to the other ratios, BC to EF and AC to DF. Those ratios all have to be the same. For example, if one of them was 2 to 3, they would all have to be 2 to 3 if these shapes are similar to each other. Okay? So then the next thing we did, again, I already have this written down because I messed up on my video. Okay? But the next thing I have here for us is I drew out 2 triangles. They don't always have to be triangles. I'll get to some other shapes here in a little bit. Okay? But for now, we're going to take a look at triangles. Okay, so I have triangle ABC again and DEF again. This triangle has side lengths of 21, 27, 36. And this one has 28, 36, 48. They did tell us that these triangles are similar. Okay? The first question they want to know is what is the scale factor from ABC to DEF? Okay, so keep in mind, take a second to think about this. Is that a reduction or an enlargement? From ABC to DEF. Here to here, that would be an enlargement. I went from a small triangle to a larger triangle. Meaning, from what we talked about a while back, my scale factor has to be larger than 1, which is something that you guys worked with on your maintaining mathematical proficiencies for chapter 8 here recently. So, what we did, and I already have written down below, I went ahead and I took my smallest numbers for no specific reason other than the fact that they were the smallest numbers. So I took 28 over 21. And again, I knew to put the large number on top and the small number on bottom because I need my scale factor to be more than 1 because it's an enlargement. Okay, for those of you who like to change things to decimals, keep in mind scale factors have to be fractions. We should not be doing decimals anymore. Okay, so what I did, 28 over 21, I reduced that by dividing both by 7. I got 4/3. Okay, if that would have been backwards and I wanted to go from DEF to ABC, that would have been a reduction, which would have had to be 3 over 4. So just pay attention to which way they want you to go with those. All right. Part B says list all the pairs of congruent angles. Okay. Well, since we know these triangles are similar, we know the corresponding parts are going to have to be congruent. This specific, the way I have this set up might not be too difficult, but when you start getting crazy shapes and things, don't waste your time with the diagram. If you know these shapes are similar, go right to the congruence, or the similarity statement. A is congruent to D. Angle A is congruent to angle D. angle B is congruent to angle E. Angle C is congruent to angle F. Okay, and we're done. Again, it might not have been difficult with the diagrams that I have drawn, but you are going to come across some diagrams that are a little bit more difficult to tell which ones go with which. So just go straight to the similarity statement and don't waste your time. Okay? And then the last thing it wants us to do, it wants us to write the ratios of the corresponding side lengths in a statement of proportionality. So that's a new one for us. Statement. I'll write that in a different color for you so it stands out. We are talking about a statement of proportionality. All that means is let's show the proportions of the corresponding sides. Okay? So again, I wouldn't, if I were you, I wouldn't mess with the diagram. Don't mess with the diagram. This one again is probably pretty easy, but they're going to get a little bit more difficult. So I'm going to go right to the similarity statement. I know that AB should go with DE. They're the first two in both. So AB over DE. Okay. That ratio should be equal to BC over EF which should also be equal to AC over DF. This is your statement of proportionality. It is showing three ratios, any two of which would be proportional. Meaning I could take these two, solve a proportion, these two, solve a proportion, or these two and solve a proportion. Okay, and we will be solving those proportions here in a second. All right, moving on. Now I'm taking a look at example 2 in your textbook. Also keep in mind as we go through this, there are videos to go with every single example if you take a look at those in your ebook. Okay? So if you need those, utilize those. So what we have here is I have two triangles. See how well I can draw these. GHKLM. GHKL and M. And I have 15, 10, 12, 15, 10, 12, 18, 27, and X. Okay, so obviously I'm going to assume that most of you are going to assume we're trying to solve for the value of X here, which would be the length of KL. Again, if I get going too fast, just pause the video for a second, get things copied down. I'm going to try to make these videos as short as possible. They do tell us that triangle GHM is similar to triangle, make sure I get these letters in right order, HKL. GHM, HKL. Okay, so I'm not trying to trick us, everything's set up nicely here for us. Okay, remember, if they are similar, the ratio of the sides has to be the same. So what we're going to do to solve this is we're going to set up proportions. Okay? Doesn't matter which sides you choose, but you are going to have to at some point choose the side that has your X value because you're solving for that, right? So I'm just going to use that first. KL goes with HM. So I'm going to put X over 12. Okay, there's one of my ratios. Now I need another ratio to be able to set up a proportion. Okay, I'm going to go here. I'm probably going to go after my small numbers again. and I'm going to do 15 over 10. Okay, notice I did x over 12 and then 15 over 10. Make sure that since x and 15 are in the same triangle, that they are both on top, or you could have put them both on bottom, that doesn't matter, okay? But since I am setting up proportions, wherever the x is, top or bottom, the 15 needs to be in the same place, okay? Because they are on the same triangle. Okay? Now, there's a couple things you could do here. Some people like to just go ahead and cross multiply, okay? And which we're going to do that eventually, okay? I would recommend reducing this fraction as much as possible just to make it a little easier on yourself. So I look at this, I see I can take a 5 out of both of these. I'm going to change this to x over 12 equal to 3 over 2. Okay, that just makes our numbers smaller and a little bit easier to work with. Okay. From Algebra 1 and pre-algebra and probably even before that, you have solved proportions. Okay, so hopefully right now you're thinking cross multiply, would be correct. Now notice how I drew those arrows, because this confuses people a lot. I am bringing everything to the top. I'm multiplying my 2 from the bottom, and I'm bringing it to the top to get 2x. My equal sign is still there, and I'm taking my 12 from the bottom and I'm bringing it to the top. 12 times 3 would be 36. Okay, so I don't have fractions anymore. I don't have ratios anymore. I just have an equation here to solve. I finished dividing by 2. X is 18. Okay, so keep that in mind. That is a mistake that I see quite often, is that people put that into a fraction, like 2 over 36 or 36 over 2. Okay, make sure you end up here with an equation so that you can finish solving it out. All right. This next one I'm just going to sketch out for you real quick. I think you would be okay on it. But I'll just sketch it out for you super quick and breeze through it. It's a very similar type problem. Where am I at here? There it is. Okay. So these triangles are similar. Just make sure here you're understanding how they have this labeled. This triangle is similar to this triangle. Okay, so look at the larger triangles here. We don't know anything necessarily about the smaller triangles. So when I'm setting up a proportion here, since this is a median and this is a median, it goes from midpoint to the vertex. They have to be proportional, or they have to be proportional to the sides, yes. Okay, so I'm going to do x over 12, because those are the medians. But when I go to do the other part, you're going to need 72, because 36 and 36 over 32. Okay, so you're going to need 72 over 32 as your ratio there. And then you would go on from there. So, wait a minute. Sorry, looking at that part, they're just wanting the scale factor. So if you're finding the scale factor, they're telling you to do 36 plus 36 over 16 and 16. But do notice that would reduce to the same thing as if you would have just done 36 over 16. Okay, so that would reduce to the same thing. Okay. All right, flipping over to page 420. We're talking about two things here, and they're just a couple last ideas here before we finish up for this lesson. 8.1 is a theorem on page 420. It's perimeters of similar polygons. Okay, and get this on your theorem sheet. It's on page 420. I'm not going to write this whole thing out or draw the whole diagram for you because you're going to have to go back and look that up anyways. So for the sake of time here on the video, I'm not going to draw that out. Okay, but what it says if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. Okay, so if, I don't know why I put two F's there. If K, L, M, N is similar to P, Q, R, S, then this following statement is going to have to be true. The perimeter, which would be PQ plus QR plus RS plus SP over the perimeter of this one, which would be KL plus LM plus MN plus NK. The ratio of the perimeter has to be equal to the ratio of your sides that we talked about previously. So that ratio would have to be equal to PQ over KL or QR over LM or RS over MN or SP over NK. Okay, so that's your theorem, perimeters of similar polygons. Now, you're not going to have to write out all of those ratios here. Okay, and you're probably not going to know all of them anyways. They're just showing that you can choose any of the corresponding sides to set up a ratio with. Okay, so the example that they give me here says your neighbor has decided to enlarge his garden. The garden is rectangular with a width of 6 and a length of 15. Oops. Okay, so I have a rectangular garden, a width of 6 feet, and a length of 15 feet. And we're going to make it bigger, so keep that in mind. We're doing an enlargement. Okay. The new garden will be similar to the original one, but will have a length of 35 feet. Okay, so I have a similar, oops. I don't know if I can put that over here. We'll put it right there. We have a similar garden, probably going to be bigger than that, but it's going to have a length of 35 feet instead of 15. Okay? The question is, find the perimeter of the original garden and the enlarged garden. Okay? Now, could you solve for this side and then know that it's the same as this side because it's a rectangle, and add all the sides together for the larger garden? Yeah, you could. Okay, you're just using a little extra time. Okay, and there's going to be things that we do later where you're going to have to use this last theorem that we just talked about. Okay, so what we're going to do, first we're going to find the perimeter of this one. Okay, keep in mind this is a parallelogram, meaning opposite sides are congruent. Okay, if it's a rectangle, it's a parallelogram. So if this is 15, that's 15. So that's a 15, 15, this is 6, this has to be 6. So 15 and 15 is 30, plus 6 and 6 is going to be 42 feet. Okay, so what this theorem is telling us is instead of going through the extra effort and finding the width here, which we don't really care about, all they want is the perimeter, I can set up a proportion that says 42 over x, because that's the perimeter of the small one. We're trying to find the perimeter of the big one, so we're going to call the perimeter currently x. So I have perimeter over perimeter is equal to the ratio of any sides that I choose. So since I know this is 35, I'm going to use 15 over 35. Okay, so basically it's cutting a step out. We're skipping a step. We're not finding the side length first. We're just going straight to the perimeter. Okay, I notice that both of these are divisible by 5. So I have 42 over x is equal to 3 over 7. All that's going to do is make our numbers a little bit smaller and nicer to work with. So now we're going to go ahead and cross multiply. I have 3x equals 7 times 42 is 294. Solve that out. Divided by 3. X is 98. So now I know my perimeter is 98 feet. And I did not have to mess around and find this other side length. Okay. Could you find that other side length and then add all the sides together? Sure. If you want to take the long way around, that's fine. That's entirely up to you. That should work in all scenarios that I can think of. This is just cutting out a step. Okay? So I would suggest utilizing that. Now, on the next one is a little bit different. This next one you're going to have to use sometimes. There's not going to be any other way around it. Okay, so what we have here is, where are we at here? It's your next theorem, so make sure you get those theorems on your theorem sheet. This one is called areas of similar polygons. Okay. This says that if two polygons are similar, then the ratio of their areas is equal to the squares of the ratio of their corresponding side lengths. Okay, so again, I'm not going to draw the diagram out, but if I had a polygon KLMN is similar to, I'm going to use PQRS again. Then the area I can spell of, make sure I want to put this just like they have it. The area of PQRS over the area of KLMN is equal to, and it's going to look pretty similar to how we set it up, but we have to add something. So PQ over KL squared. Okay, so the ratio of the areas is equal to the ratio of the sides squared. Or QR over LM squared, or RS over MN squared. Try to squeeze this last one in here. SP over NK squared. And I'll show you what that looks like here in a second. It's not going to make it too much more difficult, but this is something that people just forget about, so make sure you have that theorem sheet handy for you when you're doing your assignments and things like that, so you can refer back to that quickly. Okay, so what that looks like. If I have two similar triangles, how am I doing? There we go. I have two similar triangles, PQTSR, PQTSR, 14 and 10. Okay, they tell me that PQT is similar to SRT. So I know those triangles are similar, and the area of RST is 75 square meters. Okay, so this is an example of a problem where you're not going to have a choice but to use this theorem, because I only know one side in each triangle and there is no possible way for me to find out any of those other sides. Okay, regardless of any information, this is not possible to find any of those other side lengths. So, what we're going to do is we're just going to set up our ratio. I know that the ratio of my areas, 75 for my small triangle over x for my large triangle, is equal to the ratio of my sides, 10 over 14, squared. Okay. Now they don't show you to do this in your book, but I would recommend, notice this is in parentheses, so you can do order of operations, parentheses first, and then exponent. So let's reduce this fraction just to make it smaller. So I have 75 over x. I reduce this by dividing them both by 2 to 5 over 7. Don't forget that you still have to square that. Okay. Remember, when you're squaring something, it means you're multiplying it by itself, which actually means that you need to square the 5 and the 7. So I have 75 over x equals 25 over 49. And I'm going to drag this over here just so I can keep everything on the same page. I'm going to go ahead and cross multiply. That gives me 25x. That gives me something that I'm not going to do in my head. 75 times 49 is 3,675. Okay. And again, now you have a nice simple linear equation. I'm going to divide that by 25. And we have 147. So that means the area of my large triangle is 147 square meters. those are probably the most difficult questions on the assignment. Before I end this video, I do want you to take a quick look at example 6 and keep in mind they're asking you to decide whether those polygons are similar or not. Unless you check all the ratios of all the sides, you're not going to know. Okay, so it is possible for me to draw a diagram up here where, like if it's a triangle, I could have two sides with the same ratio, but then the third side is different. Okay, so when you're checking those to see if the shapes are similar, you do need to check all sides of those polygons and make sure they all give you the same ratios. Okay, so for example, if one is 2/5, they all need to be 2/5, because if you get one that's not 2/5, maybe it's 2/7, okay, that's not, those polygons are not similar then. So make sure you're checking into those. Okay, I will get that 8.1 assignment posted for you. Pay attention to the due date. Keep in mind that if you turn it in after the due date, it will be late, which is only partial credit at 50%. Okay, so keep that in mind. Some of you still need to get your maintaining mathematical proficiencies in too, so you need to get on that. All right. Other than that, I will have 8.2 posted up here fairly soon. That's not going to be due until Wednesday morning. This 8.1 is probably going to be due, I'd say, Friday at the end of the day. Okay, so keep that in mind. Make sure you're getting those things done. If you have any questions, make sure you contact me. Email would be best. Otherwise, hope you're all doing well. Stay healthy, and make sure you're following directions given to you.